Now we're going to apply volume to real-world situations. So in this example, water is pouring into a cone-shaped reservoir at a rate of 1.8 cubic meters per minute. To the nearest minute, find the length of time it will take to fill the reservoir from start to finish. So what this is saying is we have to figure out how much water it's going to take to fill up this cone, and then that will help us figure out how long it's going to take to fill up the cone. So first we actually have to figure out, well, what's the volume of water that it will take to fill up this cone? What is the volume of the cone? So the formula for volume of a cone is 1/3 pi r squared h. So our diameter is 5.2. So our radius is going to be half of that, which is 2.6. 5.2 divided by 2 is 2.6. And then to find the height of this cone, we're actually going to have to do Pythagorean theorem. 2.6 squared plus the height squared is going to be equal to 6.8 squared. So I'm going to do 6.8 squared minus 2.6 squared. Then take the square root of that, and my height ends up being 6.2833. So now I have the pieces I need to find the volume. 1/3 times pi times my radius, which is 2.6 squared, times my height, which we just solved for, was 6.2833. I'm just going to go type all of that into my calculator, and that will give me 44.4799. So that's the total volume of water that it will take to fill up this cone-shaped reservoir. So our volume of this cone is 44.4799 cubic meters, so meters cubed. So now I know that it's going to take 1 minute to fill up 1.8 cubic meters of water. So I can take the total amount of water and divide it by the rate. So I'm going to take the volume and divide it by the rate, 1.8 cubic meters per minute, and that's going to give me the time that it's going to take to fill up this cone. So I'm just going to divide that by 1.8, and I get 24.7 minutes. Fill up this cone-shaped reservoir with water.